You guys remember how we've talked about the membranes of the body and how they might surround an organ versus the cavity that they're found in and that sort of thing? Well, this time, something that we have to remember. We know that the lungs are contained in the thoracic cavity. Now, when I say thoracic cavity, I'm saying thoracic because it starts at T1, goes to T12, and the ribs encompass it. Okay? So this would be my thoracic cavity. Here's the thing about the lungs. The lungs are found in the thoracic cavity, but they are separated and they are surrounded by their own cavity formed by these membranes. So you don't say that the lungs are the same covering as the thoracic cavity. They're found in the thoracic cavity, but we're going to see that it's within the pleural cavity because it's surrounded by the pleural membrane. So, do you remember how we have visceral and parietal, the one that's inner, the one that's outer of a membrane? Visceral, if you remember, visceral is going to be the one that will travel all of the outlines of the organ. Okay? Parietal is going to be the one that's surrounding to the outside. And in this case, in between the visceral and the parietal, we're going to see it filled with pleural fluid. The pleural fluid. This is a fluid that's coming from these membranes, making them up, the visceral and the parietal. And the fluid, it will act as a lubricant. And the reason for that, the lungs, as we breathe, we'll need to expand and we'll need to recoil. All right? And what this will help do, because we are in the thoracic cavity, what we're going to find is that this will help these lungs expand and recoil and not be rubbing against the tissues of this cavity. That would be extremely painful if that were to occur. Have you ever heard of somebody with pleuritis? Okay? It's very painful for them to breathe. Okay? Because there's inflammation there and they're actually feeling the rubbing of this organ in their chest. And from what I understand, very painful. The other part about this, that parietal membrane is going to help hold the lungs within the thoracic cavity. So we're going to have an attachment to the outer thoracic cavity with these membranes.
Can you say that part again? The parietal membrane helps the thoracic?
The parietal membrane will have a connection with the membrane of the thoracic cavity, helping to hold the lungs in place so they're not slipping and sliding all over. It's part of the reason that our lungs can change in size. Having that attachment to this inner thoracic wall and being within their own cavity, so to speak, being within their own cavity, but having that outer portion have a connection to the thoracic wall, it's going to be one of the things that's going to help with respiration. How? If I've got my outer thoracic wall, then in that pleural cavity, I've got an outer membrane, I've got a membrane along that thoracic wall, and if I have a connection to it, what's going to make the thoracic wall move? Muscles, okay? My intercostals and my diaphragm. And it's going to make it move up or move down. Is that correct? Because isn't that the way that they move? All right, so having that attachment, guess what it's going to be able to do to that membrane? Pull it and move it. Yes. So they're going to be helpful in respiration for these membranes. So this lovely function that the lungs can do. Pulmonary ventilation. When you breathe in and breathe out, that's one cycle, and that's termed a respiratory cycle. About how many times at rest do you breathe in and out? Average, about 15. Some may have a little more, some may have a little less. So, are you paying any attention to it? No. And did you know that only one side of the nostril works at one time? Yeah, so in other words, when you're breathing, okay, if the right side is the one that's working, all right, for right now, that's the one that's going to be the air, and it lets the left rest. And then the left will start and let the right rest. I just think that's kind of cool. Yeah, you can feel it when you force the air out yourself, okay? But, oh, that reminds me of a movie I was watching. Never mind. Okay, and so, you know, but it's usually just one side versus the other at a time working. We're going to say that we're going to have quiet versus forced respiration or ventilation. All right? Muscles are going to play a huge part in respiration. The diaphragm is huge and a part for respiration. We're going to find that certain muscles are going to help with inspiration. Certain muscles are going to help with expiration. Do you happen to remember when we were studying the muscles, how I pointed out that between the ribs, the muscles did this number? Okay? So we're going to find that in this structure for those muscles in between the ribs, one is for inspiration, others for expiration. And then the diaphragm muscle that it is, sort of getting represented right here, okay? Huge muscle that's going to be a part of inspiration and expiration. So for the most part, what we're going to see, we're going to find that the diaphragm and these skeletal muscles, they are going to be the, in between the diaphragm, the skeletal muscles, the thoracic wall. These are going to be responsible for the movement, for the ventilation that we're going to find. So, what is it that's going to affect them to make them move? When we look at what happens with breathing, we mentioned, okay, that there is the autonomic nervous system, okay? When we look at nervous control, all right, the neural control, what is being received in information, okay, it's going to be dependent on the repetitive stimulation of the skeletal muscles from the brain. Now, take notice of what area of the brain. We've got pons, got the medulla oblongata, got midbrain. Okay, wait a minute. What are my lines innervating from those neurons? What are my lines trying to represent as being innervated? My muscles of the rib cage and my diaphragm. All right, is everybody following me so far? This entire process ceases if the spinal cord is severed very high in the neck. If a person has spinal cord break, C1, C2, they will stop breathing. That is pretty high up in the neck. At that area, C1 and C2, if the spinal cord is severed at that point, I think I've mentioned this before, it's considered decapitation. And if the person lives, they're actually living from having their head taken off. Like Christopher Reeve, Superman, okay? But you'll notice he had a ventilator the rest of his life. Now, these skeletal muscles, all right, they're going to require the stimulation of these nerves. So, note we have our inspiratory innervation and expiratory innervation. What do you notice about the difference? Inspiratory, expiratory. Inspiratory goes to the muscles between the ribs as well as the diaphragm. Well, wait a minute. Expiratory, why is that not affecting the diaphragm?
Just recording.
The diaphragm is going to be affected by pressures within the cavity. Now, something else. Oh. Got some groups. Yay. we're going to find that in the brainstem, we are going to have our respiratory center in the brainstem. So in the brainstem, we are going to have a respiratory center. The respiratory center has a ventral group and a dorsal group. Ventral, this direction, dorsal, that direction. Now, based upon what you can see in this picture, and if this right here is my ventral group, and if we follow this nerve coming down, what do you think that one's the most active in? Inspiration or expiration? Expiration. So if I come over here on my dorsal group, what is that one most active in? Inspiration. So in this dorsal respiratory group, this one most active during inspiration, but we also see it innervating the diaphragm. So this dorsal group, okay, right here, it's right here. The dorsal group is going to help stimulate the contraction of that diaphragm. So we've got one group for inspiration, one group for expiration. So the ventral, ventral's going to have a whole lot of an effect on establishing the rhythm of breathing.
The ventral establishes the rhythm of breathing.
When we look at the ventral, that is going to help, yes, establish our rhythm of breathing. So think of it. Do you guys remember when we were studying neurons and I mentioned a reverberating circuit? In other words, the information going in, information going out, these neurons don't really fatigue, okay? They just kind of keep a continuous circuit, information in, information out, information in, information out. This is breathing. Breathing operates on this reverberating circuit, meaning it doesn't really get tired, okay? The dorsal group can be affected by external sources. What does that mean? When you're exercising. Because when we exercise, we affect the breathing rate. And we are doing that effect. Are we not? So we have the ability to affect this, which will affect the respiration, and we start a whole cascade of events that begin to take place in the body. Yes, no, maybe.